Shani Lee, and I'm going to be the presenter for today's session. Today's session is going to be on fractions, comparing and converting, which are from lessons 7.2 and 8.1. The goals for the lesson, for lesson 7.2, are to use sense-making strategies to compare and order fractions. We want the students to be able to identify unit fractions, and then also use benchmark fractions to locate other fractions on a number line. The lesson goals for lesson 8.1 are to use a variety of strategies to convert between fractions and decimals, be able to demonstrate some conversion fluency between common fractions and decimals, and then lastly, being able to compute with simple fractions. All right, so this was the while you were waiting activity, and in this activity, this is actually from student page 8, and what we want the students to do here is to basically order these fractions using some sense-making strategies. And so for number 1, I think most of you filled out the order for this set of fractions, but essentially this group of fractions are all unit fractions where the numerator is 1 and the denominator is a positive integer. So basically what we want the students to recognize is that when you have when the numerators are the same, what we want to do is see, compare the denominator, and basically the largest denominator is going to have the smallest fractional value. So ordering these from least to greatest, we have 1/8, 1/5, 1/4, and 1/2. Okay. And then again in number 2, very similar to the set of fractions in number 1, we have the same numerators, and then now we're going to look at the denominators, and basically the larger the denominator, the smaller the fraction. Okay. For some reason though, I think with students, yes, Helen, did you have a comment? Do you want to type it in? Do you remember if students have access to the fraction strips for this activity? I don't know if they do, but I was going to mention that that is a very good tool to use in terms of comparing fractions. So thank you for bringing that up. So again, one of the misconceptions that students have when comparing fractions is they think that sometimes, for example, when I'm looking at the set of fractions in number 1, they may think that 1/8 is the largest fraction because they see the number 8. And so, you know, you may want to take some time going over that misconception that just because the denominator is has a greater integer value doesn't mean that the fraction is the largest value. Okay. One way to do that is, again, like Helen mentioned, you can use those fraction strips that we introduced in week 6, where they have the strips of paper where they fold in half and then they fold it again in half to get the 1/4, and then folding the 1/4 pieces in half again would give you the 1/8 pieces. So again, using those fraction strips would be a good idea for them to compare fractions. And also, I think using just real life situation. I know a lot of teachers tell me that they use Hershey bars to explain that if you have a Hershey bar divided into 8 pieces, 3 of those pieces is going to be a lot less than if I were to divide that Hershey bar into 4 pieces and taking 3 of the 1/4 pieces. So again, using real life context, and also maybe the fraction strips to do some comparing of fractions. Okay. How about number 3? What were some of the strategies that you used to compare and order the fractions in number 3? You can write it in the chat box, or if you have access to the mic, you can use a microphone as well. All right, so they're complements to 1. Okay, so and then Pat said to convert 3/4 into 6/8. All right. Now going back to Helen's comment, complement to 1. Does that basically mean that they're 1 unit fraction away from being a whole or a 1? Okay, so Helen says 7/8 plus 1/8 is 8/8. So correct, that they're all 1 unit fraction away from being a whole. So essentially, they're very close to 1, right? But not quite 1. Okay, and so a quick way to compare this set of fractions is to see how far away these fractions are from being 1. So for example, 7/8 is 1/8 away from 1. Okay, so it's really, really close. Okay, 3/4 then is 1/4 away from being a whole, or 1. Okay, and 4/5 is 1/5 away from being a whole, or 1. So if I were to look at it, so if I were to order these, then I know that 3/4 would be less than 4/5, which is less than 7/8. Okay, so again, we're looking at complements to 1, okay, and then using that idea of how far away from it is from 1 to order those fractions. Okay, how about number 4? Look at this set of fractions and tell me some different strategies in ordering that set of fractions. Again, you can type it into the chat box if you'd like. Okay. All right, so Helen mentioned benchmark fractions, right, and Mr. Diaz again mentioned the same thing. Looking at benchmark fractions like we did last week, I see that they're all very close to 1/2 or 1/2. So for example, 4/8 is 1/2, and so I can use that kind of as my benchmark fraction and see if the other two fractions are less than or greater than 1/2. Okay, so for example, 3/10 I know has to be less than 1/2 because 5/10 is 1/2. And then 17/25, Charlie says that 17/25 is closer to 20/25, so it has to be greater than 1/2. Okay, so again in number 4 we're using this idea of benchmark fractions to compare these fractions. Okay, and so the idea on this page is basically exploring some different strategies for ordering fractions. I know that there's multiple ways to order fractions, one being finding the common denominator for all of these fractions and then ordering them that way. Another is converting them all to decimal form and then comparing the fractions that way. But we think that some of these sense-making strategies are a lot quicker than some of those traditional routine procedures for ordering fractions. Okay. Any questions or comments on this page? Are we ready to move on? All right, let's move on to the next page. So the next 3 SP pages, what we do is we provide, we want the students to basically place the set of numbers on a number line. Okay, and so the first thing that we want to do is think about some benchmark fractions for this set of numbers. Okay, and again, looking at the numbers, I see that they're all between 0 and 1. So a good benchmark fraction to place on my number line then would be probably 0 on the left, leftmost edge of the number line, and then maybe a 1 on the other end, the right end of the number line. Okay, and then some common fractions that students are very familiar with. Those would again be really good benchmark fractions. So for example, maybe placing the 1/2 as a benchmark fraction, and then 1/4 would be 1/2 of a half, so placing that right in between 0 and 1/2. Okay, and then we can start thinking about how we're going to place the other fractions on the number line. Okay, and so let's go ahead and look at the rest of the fractions and see if we can use some of those sense-making strategies that we talked about on the previous page to place these fractions on the number line. Okay, let's look at 6/8. Okay, what are some different strategies or some ideas on where we can place 6/8? Okay, so Helen says 6/8 is equivalent to 3/4. Okay, so I know that 3/4 then is going to be right in between 1/2 and 1, so we can place the 6/8 in between 1/2 and 1. Okay. How about 6/10? Where should the 6/10 go? All right, so Shelley brought up another really good strategy. 6/8 goes right in between. Oh, yeah, so same thing as what Helen said basically. How about 6/10? Okay, Mr. Diaz says that 6/10 is smaller than 6/8, which is like 3/4. Okay. What is 1/2 equivalent to? Something that would help us in terms of placing 6/10. Can we rewrite or rename 1/2 as 5/10? Correct. So Susan says, let's rename 1/2 as 5/10. So if I know that 1/2 is 5/10 and 1 is 10/10, then I know that 6/10 will probably go 1/10 to the right of 5/10. Is that correct? Great. Okay. So again, all right, so we took care of the 6/10. Now how about 6/7 and 7/8? How can we compare those two fractions, or where can we place those two? All right, so Helen says complement to 1. Okay, so I know that they're 1 unit fraction away from a whole. Okay, and so Shelley says they're very close to 1, but 7/8 is closer, right? Because I know that 7/8 is only 1/8 away from being 1, and 6/7 is 1/7 away from being 1. Okay. Perfect. Okay. So again, 6/7 is larger than 6/8. Correct. That is correct. Because again, we have the same numerator, and since 6/8 has a greater denominator, then 6/7 is going to be greater. Okay. Alrighty. So again, we're using some non-traditional, some sense-making strategies to place these numbers on the number line. Okay. Any questions or comments about this activity or this placing the numbers on the number line? Right. Okay. All right. So let's go ahead and move on. What do you think about working with fractions this way? Yes, it's like we're all talking at once. Shelley asked a question. What do you all think about working with fractions this way? Do you think the students benefit from using sense-making strategies when comparing and ordering fractions, placing them on the number line? Yeah, it seems like everyone agrees. I agree, it does take time. I think the students have to have a really good number sense to be able to do this. And we hope that some of the previous fraction lessons really build on, kind of build to this idea. Okay. All right, let's move on to the next page. Actually, the next 2 pages are very similar to number line A, but again, it's a different set of numbers, so they may require some different, different strategies and some different benchmark fractions. We're not going to do this because you basically get the idea, but I do want to point out a couple suggestions that the teacher guide makes. There's basically different ways you can run this activity or do this activity. One way is obviously having the students work out of their SPs and then having a discussion about or sharing their strategies on how they place the different fractions on the number line. Now another way you can do this activity is to actually use paper strips that are cut out into same lengths, and then giving groups of students the same set of numbers to place on these paper strips, or adding machine tape. Okay, and so once the students place their numbers on the paper strip or the adding machine tape, you can go ahead and tape them, tape them on the wall underneath each other, and it's a really good way for the students to see how close they were to placing the numbers on the number line. And again, sharing out their strategies on how they placed the numbers on the number line as well. Okay. Any questions about the number line activity or any comments? Okay. It's like Helen said, it's very important to align the papers vertically to compare accurately, right? And then also let them know that the leftmost edge is going to be that 0 mark, and the rightmost edge is going to be the 1 mark. Because depending on where you place the 0 and the 1, the placement of the fractions might be different. Okay. All right. All right, if you don't have any other questions, I'm going to move on. Okay. All right. We're going to actually move on to lesson 8.1. And so in lesson 8.1, the students are going to, again, use some sense-making strategies, but this time they're going to use those strategies to convert fractions to decimals, and then also learn some common fraction decimal conversion facts. Okay? So here's a warm-up for lesson 8.1. Okay? And what we want the students to do is to use some different strategies to figure out the decimal and percent equivalents for 1/4 and 1/3. So go ahead and take a minute to think about some different ways you can come up with the decimal and percent equivalents for 1/4 and 1/3. You can type it into the chat box if you'd like, or you can draw pictures on the whiteboard if you'd like. All right, I know I didn't give you enough time, but I'm going to go ahead and let's talk about number 1 and number 2. All right, so for number 1, it looks like someone used the 100 square grid to figure out the decimal and percent equivalents for 1/4. And so basically shading in 1 of every 4, which is what we did in last week's lesson in the replicating lesson. To find the decimal equivalents and the percent equivalents. So I know that shading in 1 of every 4 box, I should have 25 of the boxes shaded. Okay, so 25 of 100, okay, is going to give us 25%. Okay, and then again, 25%, I know because it's per 100, I can change that into a decimal 0.25 or 2500. Okay. You know, some students might bring in their knowledge of money, so they know that 1/4 of a dollar is a quarter, and a quarter is going to be 25 cents. Okay. Some other ways to think about 1/4, they might know what 1/2 is. So I know that 1/2 is 50% or 5/10. So I know that 1/4 is half of 1/2. That would be another way to figure out the decimal and percent equivalents for 1/4. Okay. Now for 1/3, same thing. I can find the percent. I'm going to shade in 1 of every 3. So I know that it's going to be about 33. It's going to be 33 1/3. Okay, so 33 1/3%. Now coming up with the decimal equivalents for 1/3 is going to be a little bit more difficult. One of the suggestions that the teacher guide makes is to essentially do the long division procedure so that they can see why 0.33 is repeating. Okay. Does anybody have any other ideas for showing the decimal equivalents for 1/3? Yeah, I think, you know, to show that the 0.33 is repeating, I mean, the only way to really do that is to do the long division process for it. Okay, so the idea here is that we want to give them some common fraction decimal conversion facts, so they know 1/4 and they know 1/3. Okay, all right. Another a fraction decimal conversion that we want the students to know is 1/8. Okay. So on SP2, we want students to think about 2 different ways to come up with the decimal conversion for 1/8, decimal equivalents for 1/8. Okay. So one way to come up with the decimal equivalents for 1/8 is to think about renaming the fraction so that the denominator is a power of 10. Okay. I know that I can't rename 1/8 with a denominator of 100. Okay, but I do know that I can rename 1/8 with a denominator of 1,000. Okay, and I think if I multiply 1/8 by 125 over 125, I get 125,000. Okay, and so now that I have a fraction with a denominator that is a power of 10, I can convert 1/8 into a decimal, which is 0.125. Okay, and again, the same idea that we talked about last week. We're multiplying 1/8 by 1, the big 1, in the form of 125 over 125. Okay, so again, there's our decimal equivalent for 1/8, which is 0.125. Okay, so that's one method. Okay, now the other method is basically using a fraction fact that we know to figure out what 1/8 is. So we figured out that 1/4 is equal to 2500ths, or 0.25. Okay, and I know that 1/8 is 1/2 of 1/4. Okay, again, the students did some fraction strip folding activities to figure out that 1/8 is 1/2 of 1/4. Okay, and to find 1/2 of 1/4, okay, I know that it's going to be hard finding the half of 0.25. Okay, but I know that I can find half of 0.250. Okay, so there's a couple ideas here. The first idea is that the students have to recognize that 0.25 is equal to 0.250. Okay, and then taking a half of that. Okay, so half of 0.250 is then going to be 0.125. Okay. All right. So once they figured out what the decimal equivalent for 1/8 is, okay, they're asked to complete this table. Okay, so they're given some fractions, okay, and they're asked for the decimal form. So I know that 1/8 is 0.125. Okay, how can I find 2/8? How would the students find 2/8? All right, so Helen suggests that we add 1.25 twice. Okay, it's two groups of 1/8. Okay, and then again, same thing with 3/8. I know that 1/8 is 0.125, 2/8 is 0.25, so 3/8, I'm just going to add those two together to get 0.375. Okay. All right, so again, SP2 is going over 8s, and what we want the students to do is become familiar with the decimal equivalents for 1/8, and then discussing some strategies on how to figure out 2/8, 3/8, 4/8, and so on. Okay. All right. Any other questions or comments about this page? Okay. All right. So Shelley mentioned that the idea here is that they memorize a few decimal equivalents so that they can quickly figure out the rest, and it takes some practice. Yes, it does. Okay. So they've been given 1/4, 1/3, and 1/8, and with that, okay, on the next page, they're asked to figure out some other fraction decimal conversions. Okay, but again, remember that they were given 1/3, 1/4, and 1/8. Okay, so knowing those three decimal equivalents, okay, they're asked to figure out some of these different fractions. Okay, the decimal equivalents for these different fractions. Okay, so for example, in number 3, okay, we know that 1/3 is 0.33 repeating. Okay, so to figure out what 2/3 is, okay, I'm just going to add 0.33 twice. Okay, it's two groups of 1/3, so I know that that's going to give me 0.66 repeating. Okay, go ahead and take a couple of minutes in filling out the rest of these different fraction decimal conversions, and then we'll talk about it in a minute. All right, looking at the fraction decimal conversions on this page, which ones do you think the students will have a difficult time with? Do you think any of these would give them any problems? Right. Pat says 2/2. Why do you think the students would have a difficult time with that one? Do they not see that 2/2 equals 1? Right, I think Pat's still typing. Right, I think one of the more difficult ones that students struggle with is 3/3. There's a pattern here for 1/3 and 2/3. And following that pattern, it would make sense that 3/3 would be 0.99. But we also tell them that, you know, when the denominator and the numerator are the same, that it usually equals 1, equals 1. Okay? So we don't actually have enough time to go through it, but there is a note in the TP pages about why 0.99 actually equals 1. Okay, and so that might be something that you want to look at before teaching this lesson. So that might be a point of confusion for the kids. Pat says, I'm afraid they think that 1 over 1 at 100%, but 2 and 3 over 3 would create the same confusion. Okay? So they understand that 1 over 1 is 1, but 2 over 2, they might think it's 2 or something. Again, I think Shelley makes a good point here. Maybe multiplying 2/2 by 50/50th to show that it's 100 over 100. And then again, maybe even using the 100 square grid to show that it's basically shading in every single square on that 100 square grid. Okay. There's a couple other, actually there's 2 more pages here. I'm going to go ahead and move on. Oops, too far. Okay, so the next page here, again, some fractions that we want them to convert into decimals. And we want to emphasize, like we did on this page, to use some alternative strategies or some sense-making strategies to convert these fractions into decimals. Okay, I'm running out of time here, but there's a couple different strategies that I wanted to point out. One being, for example, in number 10, 11, 12, and 13, we have fifths. And a strategy for converting these fractions into decimals would be to change the denominator or rename this fraction so that the denominator is a multiple of 10 or a power of 10. Okay, and then again from there you can get to the decimal form that way. 18, 19, 20, and 21 are going to be difficult also. 1/9. So remember for this you might want to refer to the warm-up that they did, where they figured out what 1/3 was equal to. So if I know that 1/3 is 0.33 repeating, I know that 20, number 23/9, simplifies to 1/3. So using that fact to kind of figure out what 1/9, 2/9, and 4/9 are. Okay. So again, we're just emphasizing using some alternative strategies, some sense-making strategies to come up with the fraction decimal conversions. Okay. And again, same thing with this set of fractions. Okay, I'm going to use my knowledge of changing the denominator into a power of 10. I'm sorry, yeah, power of 10 to figure out what the decimal equivalents for these fractions are. Okay. All right. Any questions or comments? I know I kind of rushed through those last pages, but I wanted to make sure that we ended on time. Any questions or comments? All right, then I think that is going to be the end of the session. There's actually a game that you can play, and again, it's in your teacher guide, so it's basically fraction war. Okay. All right, I think that's the end of this presentation. Thank you so much for joining me this afternoon for our online session. If you have any questions or other comments, or if you want to discuss this further, you can stay online. We'll be online for a little bit longer. Our next session is going to be October 13th, and the session topic will be fractions, addition, and subtraction. All right, and if you have any feedback for today's session, please feel free to email me, or if you need verification of attendance, you can email me as well. Okay, thank you very much, and have a great afternoon.